So my name is Misha Reyzlin. I'm a front-end engineer at SoundCloud HTML5 team. You can see my Twitter handle. I'm living in Berlin. I moved there 1 year ago from Israel. We are going to talk about the next SoundCloud and HTML5 widget. Both are single-page JavaScript applications that are using shared JavaScript libraries and shared developer tooling such as build scripts and development server. So we are going to talk about single-page JavaScript application, a fat client, which means that all the logic, all the HTML is rendered on the client side, and the client-side logic is just talking to the API to retrieve the data. So the couple of pain points of such development is dependencies management, development vs production environment. You don't want to have debugging calls in your production environment. You want to have development environment which is really comfortable for development, and production environment which is really performant and fast. And we are using Backbone.js, and I'm going to talk about a couple of enhancements that we did for Backbone to use on large-scale JavaScript application. So let's talk about dependencies. When you write JavaScript like 4 years ago or so, this is a thing that everyone is familiar with, just a couple of script tags that you put. They are guaranteed to be loaded in this order, sequential order. You know that if you need in audio.js, if you need, for example, math.js or event emitter script, you will have it because it's just below. But there are a couple of problems with this approach. You have to do the ordering manually. You have to take care of the ordering by yourself. There are lots of synchronous requests. This is solved usually by building all these files into a minified file, but still, file names and JavaScript code are not aware of each other. This means that your HTML is defining the modules of your JavaScript application, but the JavaScript code doesn't care or know about these file names. And we have to load everything. There is no conditions in HTML except for Internet Explorer conditional comments, but this is a very specific case. You might want in your application to load things conditionally. Then there is an intermediate solution, such as lab.js, script.js, etc. These are script loaders. This is how the code looks when you use such a script loader. I don't know if you see it really well. But the idea is that these script loaders are optimized for asynchronous loading, but still you have to do the ordering manually, and you have to write these things inside of this one call to this loader library, which is still not optimal. Now, the solution for this is to use JavaScript modules. How many people here know what asynchronous model definition is and what AMD is? Okay, quite some people know that. And CommonJS, which is a standard which was developed mainly for backend JavaScript, mainly for server-side JavaScript, which is synchronous, but the idea is to export your main piece of functionality onto a property of one global exports object. We are using an approach which is mixed. So this is both AMD, asynchronous model definition, plus CommonJS. I will talk a little bit more about this now. What do asynchronous models give you is that within the model itself, within JavaScript file you're talking about, you have a clear overview of the dependencies. I will show the code in a minute. So you first show the whole dependencies you want. This lets you know while you're working on some JavaScript what it is using. It also promotes best practices. So all of your JavaScript is wrapped in a definition function, which is a closure. So this means that all of your so you don't export any globals, and you only export the functionality you need as a property of export object. And not only JavaScript can be loaded this way, also templates and CSS. I will talk about this in a minute. At SoundCloud, we are using Require.js for development and Almond.js for production. Who here knows what's Require.js? Require.js is a popular AMD library which provides a lot of nice things with it, among with Optimizer and other things. So when we are developing, this library is taking care of loading dependencies for us. I will show the code in a second. And when we are in a build version, so we have one big minified file, we still have these calls to require and define functions, and Almond.js is providing us with these runtime functions. So we don't need to change our code. It's still calling require and... sorry? After our tests, it seems that it's more performant in our case. So in our particular... sorry? Itself. Yeah, well, Almond is really tiny, so it's like 1.5 kilobyte when minified and gzip. We did different tries. This is a valid question, why not to use AMD, full-blown AMD loader like require.js in production. The thing is, we are going to experiment more with it. We are thinking about maybe doing that, but that's not something we do at the moment. Now, here is a typical AMD definition of a model. Here it's using require, but it could be as well a define call. You can see a lot of repetitive typing. We are defining an array of dependencies for our JavaScript module, and then we are passing these dependencies as parameters into our JavaScript module. This is not useful. This is just a lot of typing of the same things. Because of that, our development server is wrapping our JavaScript code in these define definitions. So what we are writing is just these simple require calls, and then when we are requesting this file while developing, the development server written in Node.js is wrapping this code with define definition. So this way we are getting proper AMD modules in our browsers, but we only type very compact modules in our, and our code that is living in Git is getting these compact representations. Now, build script. As I said, the development server that is doing these things is written in Node.js. The build script is also written in Node.js. And this means that we can reuse the same JavaScript functions that we are using for development, and we can as well wrap these modules for the build version of our JavaScript. Another thing I want to notice here is that we tried to use other build scripts. So, for example, there is a popular solution called Ant, as I think it's coming from Apache, and it's Java, I guess, also mixed with Perl and other things. This is what is cool about Node.js. You are JavaScript. I am a JavaScript developer. I want to write JavaScript. I don't want to switch my context. I don't want to switch my tooling. I want to write JavaScript. This is why writing things in Node.js is much easier for me as a JavaScript developer than to switch technology to use something like Ant. The resulting application that we are having in SoundCloud is just HTML, CSS, and JavaScript. That's it. There is no server-side technology. The build script is written in Node.js, but the resulting thing is just HTML and CSS that is talking to the HTTP API. The build optimizations. Now, as I said, you don't want your development environment and your production development environment be the same. They should be completely different. While you are developing, you want to have different calls to console logs, different calls to other things. You want to have forked logic. If I am in this environment, then do this. What we are doing is we are using Uglify.js to parse JavaScript files. So we are not using some kind of regexps to cut out okay, I'll just show example of the code so it's clear what do I mean. I'm not sure if you see the code really well. The idea here is that while in development mode, we are defining different ifs. So if we are in an environment that is production, we will use some particular client ID. When we are developing, we will use another client ID. Client ID is a key that we are using to access API. So we want to be sure that when we are developing, we don't log the same usage that we would get in production. And then you can see some console log call. So we are using Uglify.js to parse JavaScript files, and then we can manipulate this JavaScript as we want. For example, we can replace constant values. So you can see that environment was replaced by production, and debug mode was replaced by false. Now we have if false, some condition, console log. Then we can use AST squeeze. So this is what we are getting from Uglify.js. It can remove dead code. So while in development we had this console log code, Now we will have if false, so Uglify.js knows that this is dead code. It will never enter this if, because it was if false, and it will completely remove this unneeded code, and in production we will only get a very tiny, whatever, 8 or 9 bytes of code, instead of all the thing that you have seen here up in the upper piece of code. So don't use regexps to play with your JavaScript code. Use full-blown parser, which provides you with really nice access. As I said, abstract syntax tree is like DOM for HTML. It allows you to actually have a JSON object which lets you know this is a function call, this is a comment. For example, to remove comments is like extremely simple because you just have a big object in which you have a property called comment, and you just throw this away, and then you can generate JavaScript code out of that. Another thing that is a build optimization we are using on our Node.js build script is lazy evaluation of AMD modules. What we are doing is wrapping our JavaScript code in a string. Why we are doing this? As you can see on the left image, there are typically 4 steps for JavaScript file to be available for you in the browser. First, there is a network latency, such as DNS resolving. Then there is a download phase, actually downloading the file from the server. Then there is a parsing of JavaScript file, and then there is evaluation. As you can see, evaluation can take almost as much as other 3 things together, depending on the complexity of your JavaScript. What we are doing is we are wrapping our JavaScript in a string. So when the code is delivered to the browser, it's just a string. It doesn't do any evaluation or parsing of this code. And when the AMD loader, so Elmon.js that we patched, knows that we requested this module, it then evaluates this. So this makes the process of initial loading much faster. We don't need to parse all the JavaScript. We don't need to understand all the JavaScript. Browser doesn't need to take care of this at that moment. We only evaluate JavaScript when it's needed. All right, now let's talk about backbone enhancements that we are using in SoundCloud. We are struggling to make everything as small and independent as possible. I will talk a little bit about the views. This is kind of a main kind of modules in our system. The views should be independent and reusable. They can include subviews and subviews and subviews. I will show a little image. So all the application is one big view which contains a lot of subviews. Mostly the views should be very small, except for the big wrapping ones, and they must play nice. What does it mean must play nice? Is that they should be able to detach event handlers that models have, for example, as references, so that when you use your application for a while, the memory consumption doesn't grow crazy and your tab doesn't crash. Views should not know anything about where they are included. Views should not ever know who is including them. They are completely independent. They do not know who is their parent. And the subviews that we have a constant reference to all the subviews. This means when we are destroying the current view, we will also destroy the whole set of subviews, which will let our application be snappier. The coding style. Here you can see the definition of a view, a typical definition of a view. We have a couple of dependencies on the upper part of our module, and then we can load a template and the CSS also as AMD require calls. I will now talk a bit about these things. We are using Handlebars templating engine, the one written by Yehuda Katz, the guy behind Rails 3 and Ember.js and some other cool things. The Handlebars templates are something that we came from Mustache.js. They're almost logicless. They allow for looping through the nodes. They're precompiled for speed. What does it mean, a precompiled template? It's just a JavaScript function which takes as a parameter an object and returns a string. So this means that precompiled template is just JavaScript, and that's why it can be easily loaded as AMD module, because it's just a JavaScript. And we can define custom helpers, which are just JavaScript functions that return HTML string. So you can use inside of your template. You have seen now CSS AMD modules. Are you sure if that's a good idea to load CSS within JavaScript? Not so used to this, right? We usually have just style tags. No, what we are doing is that we have one CSS per one view. So we always, our views are really independent, and even CSS is coming as a part of that view. What does it mean, CSS AMD module? Here is an example of what it actually means. We are writing CSS, then our development server or our build server, in both cases, is wrapping our CSS with this kind of thing. So what it does is actually just creates a style tag and appends it to the head. So our CSS that we wrote as regular CSS is being minified, being put into such JavaScript definition, and then when the module is loaded, the needed CSS is attached to the head of the current page. There is a limitation in Internet Explorer, of course. Internet Explorer up until 10 only knows to load 32 style tags. This limitation we overcame by detecting that it's Internet Explorer and then just appending this CSS to the same style tag already existing on the page. This works performant enough, and all the rest of the browsers are really fast and have no problem at all doing this. Works really fine for us. As I said, you can define custom helpers in Handlebars. So we have a custom helper called view, which just initializes a view when we supply a view ID and an ID of a model that we want. Here is an example of a page. Everything that is having a border here is a view of the same model. Yeah, the title didn't fit. So idea is that we always have the same model object, and all these views are rendering the same model. So you can see, for example, a couple of play buttons, the waveform, the title. These are all separate views. Here is a better example of how actually the views look. Here is a reference to model class. And let's talk a little bit about models. Models in SoundCloud have identity map behavior. Identity map is a design pattern which means that your constructor always returns a reference to the object that already exists. If it doesn't exist, it creates a new instance, but you will not have, it's kind of a singleton, right? You always have just one object with certain ID. You can see here that I'm creating two new sounds with ID 123, but actual object is the same. We can compare them. This is the same object. How this is done? To make it, this is a bit simplified. Our views, when they are being initialized, if they have model class property, they will try to get an object from instances of this constructor. We have a static property on each model class, which is called instances, that will be able to return an instance with particular ID. So we are trying to get an instance of this model class. If it's not existing, we are creating a new one. If it exists, we increment the usage counter. Why would we increment the usage counter of this instance? I will explain it in a second. But this way, generally, we always have only one instance of certain model with certain ID. This lets us be sure that all the views on the page are always synchronized. When we change, when we like a sound, for example, we know that all the views will know that this sound is liked, for example. All models are only fetched once. We know that when we create a new view for some ID, we already fetched this ID, so we know, and we'll just use this same object. Different views are synced, and nice side effect, we can use the response fully. What does it mean? The API typically returns, for example, this is a typical response of a track representation from SoundCloud API. We have a data for track, such as ID, image, etc., URL, but we also have a compact representation of a user that is owning this track. What we can do is we can reuse this data and initialize a new object of model user with ID 12 immediately. This means often when you are developing an application, you know that, for example, for a song, you will want to have a little widget with an author and a link to the author's page. So, for example, this way, we don't need to do an additional call to the API to get the user's data. How do we know that this compact representation is sufficient for this particular view? We have this required attributes property, which will let us know that this particular view only needs these two properties. When these two properties are there, we don't need to actually fetch the model from the API. We will immediately initialize the view. There is no need to do an additional call. unless there is more attributes that we need, and in this case, and if we are going to the user's page, for example, we want to show all the data about this user, and in that case, the required attributes list will be much bigger, and we will actually fetch the full representation of the user. Since we are holding references to all the instances of all the models that we are creating, we should care to release them from time to time. This is why we incremented the usage counter when we created a new object of a new instance of model. So what we are doing is when the view is being destroyed, it releases the model instance and decrements the counter of usage of these models. This way, we can do the garbage collection manually and delete the references to the models, and our application and our tab will not crash again. SoundCloud really loves JavaScript. We do a lot of JavaScript development. We are also hiring. We are sitting in Berlin in fantastic, really nice office. Berlin is great, so look at the jobs on SoundCloud.com and come and join us. Thank you. Any questions? So the question was, doesn't it bother us that the code that we are seeing in the debugging tools, for example, are not the same that we are seeing while developing the code in our editor? So the thing is that actually while developing the difference is only 2 lines, the one at the top that is defining the dependencies and the one at the bottom that closes the closure. So except for this, usually the difference in the line count is just like 1 line count. And you can also set // source URL comment, which will let you actually refer to a particular file on your disk. And then in the debugging code, you will see the particular file. So that's just a feature of web developer tools in Chrome and Safari. And that way you can actually debug against. But as I said, the valid question, but in our case, the difference for development is really tiny. Why didn't we use the required JS plugin for CSS? Well, I guess that is just because we really like to write our tools ourselves. And another thing is that we can actually control everything we do and get so I guess that's just because we did it ourselves and we like to have control over all the things we do. Yeah. So the question is if we open source some of the stuff. We are currently working on releasing this set of base libraries for Backbone, the things we extended. So for example, identity map for models and the tying up with Handlebars, but it's still in the process. But there are other things. If you go to github.com/SoundCloud, you'll see quite some JavaScript libraries that we do have. Sorry? Yeah, actually, I finished them like yesterday night. And I'll talk to Eyal Sela, and they will be probably somewhere uploaded. I'll have them. So, okay, sure. So I'm sure you'll have a way to get them. Yeah. Okay. Thank you.